Good afternoon.
Good afternoon.
Good afternoon.
Afternoon.
All right, well, let's see who we have here today. Joran.
Here.
Rachel.
Here.
Alana.
Here.
Nathan.
Oh, we're on the
Here.
All right. Oh, okay. So the camera in St. John's is kind of pointed up. I don't know if you guys know how to use it to tilt it down a little bit. All right, David.
Here.
Okay. Chloe.
Here.
Aiden.
Here.
Rhett.
Here.
Here.
Denon.
Here.
Skylar.
Here.
Hannah Whipple.
Here.
Let's see. Joseph's not there, right?
No, he's not.
Okay. And Hannah's in.
Figure it out.
Here.
All right, you guys need to settle down there and mow you on. Come on. All right. So, first of all, let me just apologize for yesterday. I hate missing class, but we had kind of a family emergency, and so anyway, I wasn't skipping out on you. I actually kind of hurried back, and I just was about 15 minutes late, but they had already pulled the plug. So anyway, so hopefully, well, I don't know what's going to happen there, but anyway, I do feel bad about missing yesterday. But hopefully that gave you time to do the quizzes and everything's cool there. So any questions, comments, concerns about anything right now? Okay. All right. Well, today we are going to start in on 1.4. Okay, let's see here. Okay. Now I can finally see myself. Okay, so let's... All right, here we go. Okay, so 1.4, graphing with, and I kind of changed this to software. It could be calculator, could be computer work that we're doing. We'll just kind of see. Right now, I'm focusing today on using the calculator, so hopefully you've got your graphing calculator today. All right, so we're just going to use some terms to kind of focus what we're doing. It says we use the term zoom square or square window when the units or scales on both axes are the same. So now it might not look the same because, it's like your TV screen. It used to be that TVs were more square, but movies would come out and you go to the movies and the screen is rectangular. And so then you'd, watch a movie on a TV, and it used to say, I'm sure you've seen that, where it says this film has been modified to fit your screen or something like that. It used to say that a lot more. But nowadays, TVs are more the same proportions as movie theater screens. But it used to be really kind of funny when you'd watch a movie on TV, and sometimes like the picture at the movie theater would be this big rectangle, and then on your TV screen it would be this square box, and they would be talking to people that were off screen, and it was just kind of weird. Sometimes the editing was really poor. But they've gotten better. And then, like I say, TVs now are more elongated than they used to be. But it's the same idea with the graphing calculator. Is the calculator screen is not a true square. And so when you do press zoom square, so zoom and then zoom 5, what that is it makes it so that the dimensions look the same. Okay? So like a tick mark on the x-axis and the y-axis are the same distance. Normally it's not. And so your graphs are stretched or elongated. And that's going to come into play in just a minute. All right, so the first thing that we want to learn how to do is to manipulate the window. When we're looking at a graph, okay, so let's say here's the y1, all right, and we're looking at, so this is the standard Zoom 6 picture, okay? Well, we can see some x-intercepts, but we're not seeing the top and the bottom. And so usually that's not good enough. All right, now if I change the viewing window, and to change a viewing window, if you just press window, and then you can change your X-min, X-max, Y-min, Y-max. So this is the standard viewing window from -10 to 10. Okay? Now, the way I've written it here, -4 by -50, 10. The way it works is that in the first interval, you're given the X-min and the X-max. The second interval is the Y-min and the Y-max. All right, so we've changed this window, and we look, and now, I mean, it's definitely zoomed in, but I'm still not seeing the top, and I'm actually not even seeing this other part at all. All right, now this third viewing window from -4 to 10 by, and you can have the X in the middle or the word by, -60 to 60. Well, now I'm seeing a clearer picture of what's going on in this graph. And so, I mean, you don't want to zoom out so much that it looks like a line, but here you see all the details that you need. So this is clearly the best viewing window of the three. Okay? So, the idea is that you want to center the picture, the screen, so that you see all the information that you need. Okay? All right. So the first practice, use your calculator to determine which viewing window displays the most appropriate graph. So you want to be zoomed in the most, but where you see everything. So I'm testing to see if you can, key in this function into your Y1 and then change the window. And then we'll vote on which one is the best. If you run into any trouble on the calculator, then just holler. All right, so Lana, which viewing window do you think is the best? A, B, C, or D?
D.
B?
D.
D.
Oh, D? Yeah, I think D. D is right because you see this whole picture here, whereas if you see, you might only see part of this if you graph it, use a different window. So, anyway, any questions on that? Anyone feel it ought to be a different one than D? Okay. All right, scaling. Differences in scaling can cause visual distortions that may lead to misinterpretations of the graph. Okay, so let me give you an example here. So let's say we had a graph. So this is the square root of 9 minus x squared. All right. So I graph that, and so I get this graph right here. All right. Now, like what I said before about the distortions where the graph is actually the normal viewing window of the calculator, it's stretched horizontally. So if you were to, so this is what it looks like under the standard viewing window. So if you did zoom 6, you would see this. But really, it should, the actual graph should look like that, okay? In that it's actually a semicircle. So the way to make it look like a circle is instead of doing zoom 6, zoom standard, that's when you use zoom square. And so zoom square, zoom 5, that makes it look truer than to the actual graph, okay? There's not the distortions, okay? So this says graph the functions y equals x, so you put that into the y1. Y equals negative x plus 3 radical 2, so you put that into y2, and y equals the square root of 9 minus x squared, you put that in the y3. So you use the same viewing window. And then see if you can answer the question, what is true at the point of intersection? So when I ask you to do a graph like this in the calculator as a practice problem on the guided notes, just do like a rough sketch on the guided notes so you kind of see what we did and that you did in fact put it in the calculator. But don't feel like it has to be perfect. I'm just trying to teach an idea. I'm not going to have you spend 20 minutes making the graphs look perfect on your guided notes. So just do a rough sketch based on what you see in the calculator. All right, so Aiden, when you've got it, tell me, what do you notice about the point of intersection?
Well, without using like the calc intersect tool, it looks like it would be like 3, 2.
Okay. So if here, so if you look at it, it's about, so 3, 2, we could calculate the exact point of intersection, but that's not what I'm asking here. Okay. Is there anything else you notice about that intersection point? Anybody? Okay, so this is what I'm trying to teach from this practice problem, is that when you're trying to look at the graph and try to see any kind of relationships, don't use the standard viewing window. You want to use zoom square, because things like the fact that these lines are perpendicular, they don't look perpendicular here. But when you do zoom square and then even zoom in there, you can see relationship like that lines are perpendicular or parallel, or there might be some other thing that you might notice. But if you're trying to get some visual confirmation that, okay, this line is tangent to whatever, some things like that, perpendicularity, you're not going to see unless you do zoom square. Okay? All right, any questions on that? Okay. All right, part 3, near vertical line segments. If the denominator is 0, at some x value, the calculator may produce near vertical line segments. Okay? So if we're like, say with this graph right here, y equals 1 over x minus 1. Okay? It might produce near vertical line segments, but really there is a vertical asymptote. And so what happens is that sometimes your calculator, if the line segment that you graph is so vertical, it'll actually just stop graphing it. Okay? Because a true vertical line fails the vertical line test. It's not a function. So if the calculator it gets closer and closer to being a vertical line, sometimes it can't do it. Okay? So I just kind of have to warn you. So depending on how your window is, the zoom, the function, it might just drop off graphing as it gets to be okay? Other weird things. All right, so let's say if we were to graph y equals sine of 100x, and you do zoom standard, it kind of looks like some weird heartbeat or whatever. You do zoom trig, and it kind of looks like a sine wave maybe. The last window, I'm not even seeing all of it. The last window that I had up there, okay, this is still looking like a sine wave or something. All right. But and so when you zoom in, then, you see kind of a weird thing. And so you zoom in until you can maybe see a little bit better about what's going on. Okay. So zoom trig takes you from -2 pi to 2 pi. And so that's good for a lot of trig functions. Or just zooming in or changing the window. You need to be able to manipulate it. And that's really the work when you're doing it on the calculator. The real work is finding the right window. Okay? All right. Okay, so go ahead and do this graph, y equals 1 over 2 minus x in your calculator, and just do a kind of a rough graph on your paper. Okay, so what I'm curious about here is on your calculator, do any of you see a vertical line like this? connecting the two pieces. Okay, so so you do, anybody else? See a vertical line like on this first graph. Okay, so is that Aiden? Anyone else? So Aiden, what calculator are you using?
TI 83 plus.
Okay, an 83 or 84?
83.
Okay, so here's the deal, is depending on the zoom and the model of the calculator, see the older calculators would sometimes throw in this extra line. Or if your zoom is such that you might see that. But that line is actually the vertical asymptote. And it is not part of the graph. Okay? Now, if you want to draw in the vertical asymptote, that's fine, but you would do it with, like a dotted line. You don't make a solid line for your vertical asymptote because it's not part of the graph. So if you put in that vertical line as far as a graph goes, it would be incorrect. Okay? So Aiden, you need to know that your calculator is going to sometimes throw in that vertical line, that vertical asymptote. So you need to know not to include that. Okay? And now, anyone else see that, a vertical asymptote there? Okay. So as schools are, getting more of the TI-84s, we don't have to worry about that quite so much. But if you are using a TI-83, by the way, Aiden, by the time we're done with Calc 2, you're probably going to wish that you got a TI-84. So I don't know if you can get one from the school and just borrow it and then just use that at home. But there's going to be certain times when the TI-84 is going to make a whale of a difference. Okay?
All right, I'll ask if they have one.
Okay, great. Okay, next. All right, so sometimes we need a computer to understand what is happening to the graph. All right, now, especially if we're doing three-dimensional calculus. But I'm going to just kind of keep it simple here. But I'll just tell you, when I took Calc 3, I really struggled with it because I don't visualize the functions as well as a lot of my students do. Okay, and so I really could have used a computer or something to actually see some of the three-dimensional stuff. I did have one professor that could draw three-dimensional graphs really well, but I frankly have a hard enough time drawing two-dimensional graphs. This is not my skill set. But so in Calc 3, we actually do use a computer program and so on to visualize some of the 3D graphs. All right. Now, what is this? Let's see. Well, we don't really have to worry about this, other than I'll just say that the better the calculator, the more it knows. The more like the order of operations or so on. But I think everyone's using a graphing calculator, and at least the TI-83 or 84. So I don't really have to worry about order of operations here. All right. Now, so let's say I'm wanting to graph, okay, cosine x plus 1 over 200 sine 200x. Okay, that's kind of a weird graph. And then you look at this, and initially it looks like a normal graph. Okay? But what is happening is this sine 200x. See, if I zoom in on just part of the graph, I want you to see what this part really looks like when we zoom in. So it's like a sine wave made up of sine wave or cosine wave or whatever. But see, you would have to zoom in pretty far to see that. And so sometimes it's not obvious. It's not obvious. So if I tell you to fix your window like that, it's usually because we're seeing something really weird going on. Okay. Okay. So let's try. So this one. And needless to say, I don't know if I don't know if I reminded you last time, but when we graph any of the trig functions, we want to be in radian mode. Okay, so make sure you're in radian mode before you type in to the y1. Okay. So again, this is another one of those that if you're looking at the standard viewing window, it might just look like a regular sine or cosine graph. But if you zoom in, you'll see that it's like a wave inside the wave. So if you don't see that on your graph, then zoom in until you do. So just zoom in, or you can set this as your window right there. But if you just go and zoom in anywhere on the graph, then I just want you to see that sometimes there's hidden weirdness going on. All right, anyone having any trouble? Okay. All right, obtaining a complete graph. Some calculators will not graph values for x less than 0 for certain functions. So what am I talking about here? Well, okay, so put this into your y1. I know this is an example, but I just want you to see that, okay, so we have either put it in as y equals x to the 1/3 or the cube root of x. And see, the difference is that some of the older calculators, so I'm real curious, Aiden, on your TI-83, if it's going to show both sides of the graph or just the positive values.
It looks like it shows both sides.
Okay, that's good. That's good. Because you want it to. But just, so is everyone showing both sides of the graph? Anyone's not? Okay. So some people, I've had, the reason why I go through this is that I've had some students download emulators for their smartphones. And because it looks like, excuse me, because it looks like a graphing calculator, they think it's all right. But then as we start putting in some of these weird graphs, it doesn't really work well. So anyway, so that's good. Okay, so now how would you graph something like this? Can anyone tell me? Please, go ahead. John, how do you do it?
You have to make it so y equals x 25. You have to move the
So you have to solve it for y.
Isolate the y.
Okay? So you isolate the y, and how do you get just y by itself? So what's the algebra here to solve it for y?
Subtract x. And then
So subtract x squared.
So it's x plus 5.
Then what? X plus 5. Okay, if you take the square root, you don't take the square root of each of these separately. You have to take the square root together. And you have to put plus or minus. Whenever like if you have x squared equals 25, and you solve for that, you have to put plus or minus 5. So you have to put a plus or minus when you're taking the square root. Okay? Well, so where's the plus or minus key on the calculator?
there isn't, I don't
There
think.
is not one. Very good. Trick question. So then how do you put this in?
You do two separate, one for the plus and one for the minus.
That's right. So you're going to put in one for the plus and one for the minus. So go ahead and do that and just see what the graph looks like. Okay. I think I've lost my board here. All right, so Rhett, what does the graph look like?
It's like two semicircles that kind of make a circle almost.
That is correct. Okay. So, again, the reason why you have to do it that way is because a circle, in and of itself, fails the vertical line test. So a vertical line would hit a circle more than once. So a circle is not a function. So what we're doing is we're sort of tricking the calculator to graph the top half and the bottom half separately so that it is a function. Okay? All right. Any questions on that? Do any of you have like any gaps like near the x-axis? Okay. So again, the reason why that is because at that point, the graph is almost vertical. And so your calculator freaks out. It can't do vertical lines. And so you might see a little gap there. But when you're graphing it on your paper, you know it's a circle. So just go ahead and connect both halves. Okay? It is going to be a circle. All right. Now, this next part is super important for a lot of applications. Matter of fact, of all the stuff that we do, this is what you're going to use in like a physics class or a science class or whatever. It says if there is no known principle or physical law relating the independent and dependent variables, the overall trend of the collected data can be found by using a stat plot, or some books call it a scatter plot. It's the same thing: scat plot, scatter plot, stat plot, or scatter plot. So, and so in scientists in the real world, as they're analyzing data, they will use these a stat plot. Okay, so what we're going to do is, so this is like a stat plot, and so the idea is that we'll take data and just type it in and graph it. So let me say a couple of key things though, okay, about example 6, and then I'm going to have you put in the data on the sheet. So if you'll notice that this is how like my raw data is: tuition and fees at the University of California. So here's the year, and then here's the cost. And so we're looking at the increase. Now, this is how it looks like in the calculator. So to get to the list, to where you type that in, you press Stat and then Edit. So Stat Edit is where you put in your list. Okay? And so then you would type in your list. Now, when you press Stat Edit on your calculator, is there anyone missing the L1 and L2? Because that's going to be an issue for us if any of those are missing. Okay? All right. Well, let's go to, okay. The next thing I want you to notice is I'm putting in the data. The cost here, I'm just putting in directly how it is. But the year, you don't put in the year. The first year as you're collecting data starts as year 0. And then you just count from there. So I'm collecting data every 5 years. So year 0, then 5, 10, 15, 20, and then 21. So you just count how many years from the first year. So year 0. Okay. So then once you have your data in, then to get it to graph, above the y equals, you press stat plot. So it's second stat plot, and then the first option is for you to turn it on. So you press enter, and you can just turn it on. And then you can make it look differently. You can make the mark, and in this one you can change the color or whatever. But then you press graph, and you may see the data. But here's the problem, okay? 2 things with this graph. Number 1, I have this other function going on. So if I don't want that, go to your y equals and clear that, delete that. All right, now I'm going to go back to my graph. Now see, I only see part of my table here, part of the graph. So, and sometimes if you just press graph, you won't see any of it at all. So what you have to do is press zoom stat. So zoom 9, and that will zoom to your data. Okay. Any questions? All right, so now so practice 6, this is the deaths of tuberculosis for the years 1970 to 2006. So what I want you to do is put this data into your lists, your L1 and L2, and then I want you to create a stat plot. Okay, let me know if you get stuck at all. Okay, so your stat plot should look something like that when you do zoom stat. Okay, is anyone having any trouble putting the data in or getting the stat plot? Okay. All right, the next thing is to find the linear regression. So you might remember in algebra when you would do plot data points, you would get a ruler and draw the line of best fit. Okay, so the line of best fit is the linear regression. So the way that you do that, So the way that you do that, if you go back to your stat menu and then calc for calculate, stat, calc, and there's all these different regressions. So the linear regression is the line of best fit. The quadratic regression is the parabola of best fit. The cubic regression is the cubic of best fit, and so on. Okay? And so we'll do different, if you keep going, there's a sine regression, and so on. So we're going to do the linear regression. So you do stat, calc, and then you come down here to option 4. And then on this, so it says use L1 and L2. Yeah. And then calculate. And so then it gives you a linear regression. Now, when you're writing the linear regression on your paper, you don't have to write all this, just 3 decimals. Carried out to 3 decimals. Okay? All right. So go ahead and do the linear regression for this data here. All right, so Rhett, when you've got it.
Your A is negative 111.038 and your B is 40,049.417.
Good. And so then to actually write the equation, you plug in the A and the B into y equals AX plus B. So I would want you to write it like this on your paper. Okay. All right. Any questions on that? Okay, so now the quadratic regression, again, you're going to have the same data. So you do stat, calc, and then the quadratic regression is number 5. And then you just, come down here to calculate. And this time it's going to give you ax squared plus bx plus c. So this is the equation of the parabola that fits the data the best. Okay? So go ahead and calculate the quadratic regression for this data. All right, so David, when you've got it.
Do you say my name?
So what do you mean, like, what do you got?
When you have the quadratic regression.
Yeah, are you asking for the values?
Yes.
So like what A equals?
Sure.
A equals 103.64.
No. Let's double check. Did you get this linear regression?
I didn't get the same as you know.
Okay, so let's go back. So we've got to make sure that you put the data in correctly. Okay? So you do stat, edit. Okay? Now, so the list one in this, we start with the year. So what do we put instead of 1970?
1,
0.
0.
So the first year that you're starting to collect data is year 0. Okay? All right, so then what would the next year, what would 1975 be?
Would that be 1?
No. So starting, if 1970 is year 0, then it's 5 years later. So then it's 5.
Okay.
And then 10,
10 and 15.
15, 20, 25, 30, 35.
Yeah.
So it's 15 and 35. It's 50.
Okay, so, and then the L2, you can just type in those numbers just how they are.
Okay.
And so once you have them all in there, then do stat, calc, quadratic regression. So stat, calc, 5. And then tell me what you get. So what did you get for your A?
Oh. A equals 4.14.
So 4.14. Okay, so that's going to be it. Okay, now the last two parts of this says graph each regression equation on the same window as the stat plot. So what you can do is type this in for the Y1 and this in for the Y2. And then you'll see the graph. Okay? And then the last thing, use each equation to predict the number of deaths in 2020. So from 1970 to 2020, how many years is that?
50.
50. So you plug 50 in for X into each of these equations and calculate it. So we'll check that on Monday, but we're kind of running out of time here to do that right now.